Consider the function fx is equal to mod x minus 2 plus mod x minus 5, where x belongs to real number. Now we have two statements. The statement 1 says f dash 4 equal to 0, that is differentiation of the given function at x equal to 4 is 0, and the statement second is saying that f is continuous in closed interval 2, 5, differentiable in open interval 2 to 5, and f of 2 equal to f of 5. Now we need to check whether statement 1 is false, statement 2 is true, and so many given things are there. So let us check which one is the correct option. So let's go to the next whiteboard to do this question. Now fx is given as mod of x minus 2 plus mod of x minus 5. Let us start with the second option, because it is confined in the interval 2 to 5. All the informations like it is continuous in 2 to 5, differentiable in 2 to 5, f of 2 equal to f of 5, so many things are there in that interval. So we take the case when x is lying between 2 and 5 both included. So first thing what we check, what will be the value of f of 2, and that can be calculated by substituting x equal to 2. So that gives 2 minus 2 mod plus 2 minus 3 mod, 2 minus 5 mod, that gives 0 plus mod of minus 3, and we know that if any number is there inside the mod we take its absolute value, so that turned out to be 0 plus 3, that is equals to 3. Now if we wish to find f of 5, we substitute the value 5 over there, so we get mod of 5 minus 2 plus mod of 5 minus 5, and that gives 5 minus 5 is nothing but 0, and 5 minus 2 is 3, and its modulus will be the absolute value of 3, that is nothing but 3. So we can say that f of 2 is equal to f of 5 equal to 3. Now let us check the behavior of function in the entire interval when x belongs to 2 to 5. That is, when x is lying between 2 and 5, what will be the value of function? Now we know that fx is mod of x minus 2 plus mod of x minus 5. When x is lying between 2 and 5, that is x is greater than 2, so any value which will be coming over here, like say for example 3, that will give 3 minus 2, which is definitely greater than 0. So we will open this modulus as it is by putting x minus 2. Now we know that x is less than 5, so this modulus will have a negative quantity inside. So to open this modulus we need to multiply a minus sign outside, so that will be minus of x minus 5. So that will give x minus 2 minus x plus 5. This minus x and this plus x cancel out, so 5 minus 2 equal to 3. So fx is equal to 3 throughout the given interval excuse me, that is when x belongs to 2 to 5. So we can say that fx is a constant function throughout. So f dash x in the complete interval will be 0, that is when x belongs to 2 to 5 open interval, because we can't take the differentiation at end points. There only we can take the right hand differentiability and left hand differentiability, and that also satisfying here. So f dash x is equal to 0, and we know that 4 lies between 2 and 5, that is it is lying between the interval 2 to 5. Therefore f dash 4 is also equal to 0. So from all this information, this will say that statement 1 is correct, and apart from that When we have checked that f dash x is differentiable in the given interval, fx is equal to 3, that is continuous, and f of 2 equal to f of 5, these all things says that statement 2 is correct. Now, by the rules theorem, we know that if f of a equal to f of b, then f dash c will be equal to 0 for any c which is lying between a and b. So, from that we are sure that there will be some number which is lying between 2 and 5, for that f dash x will be equal to 0. But we are not sure that it should be 4 only. It can be any other number also. So we can't say it by surety that it is explaining the statement 1 also. So the correct answer for this question will be statement 1 is correct, statement 2 is correct, but statement 2 is not the correct explanation for statement 1. So let's check which is the given option there. This is the option number C, which is the correct one.